Welcome to an exclusive behind-the-scenes explainer. I'm your host, but today I am stepping fully into the shoes of a veteran Cambridge Assessment International Education Chief Examiner. I want you to picture this exact scenario. It is late in the marking season. I am sitting right here at my desk, a large black coffee in hand, staring down an interactive digital screen that's loaded up with thousands of exam scripts funneling in via the Cambridge portal. Right now, on my dashboard, I have a scripts marked today counter ticking relentlessly upwards, and a mark verification meter hovering, just waiting to hit 100%. Today, we are pulling back the curtain on the Cambridge AS and A-Level Mathematics 9709 syllabus. Specifically, we are diving deep into the 084 Probability and Statistics 1 module, tackling exactly how to secure top-tier marks on mean, median, mode, range, IQR, and standard deviation for the Mathematics 9709 AS and A-Level exams. I'm going to show you exactly what I experience as an examiner while reading your work. We are going to pinpoint those exact microscopic moments where your answer either climbs gloriously into the top-tier marking bands or drops devastatingly into a failing threshold. Okay, let's dive into this critical examiner alert right off the bat, because this is where dreams are either made or broken. It says students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. Listen to me carefully here. When I sit at my marking desk and open a brand new script, the very first thing I look for is absolutely not the little number sitting at the bottom of the page. It's the journey. Your method is your safety net. It is the exact defining moment an answer climbs into a top-tier band. I honestly cannot tell you how weary it makes an examiner to see a brilliant, clearly capable mathematical mind forfeit 6 whole marks on a complex standard deviation question. Why? Simply because they punched the raw data into a calculator, skipped writing down the formula, and scribbled down a final decimal that just happened to be off by one single significant figure. It is heartbreaking. If you show me your formulas, if you physically write out your substituted values, I can award you those precious method marks, what we in the trade call M1 marks. You have to give me the ammunition to give you points. We have a strict, time-blocked agenda today to audit exactly how a Cambridge examiner views your exam script. We're hitting the examiner mindset, the procedural framework, securing method marks, evaluating evidence, the top 3 warnings from the grading desk, and the final exam strategy. Right. Section 1, the examiner mindset. Let's build the theoretical architecture and see what happens in those crucial first 15 seconds of scanning. When a high-tariff, multi-part past paper question flashes onto my screen, my eyes immediately perform a rapid 15-second structural scan. As a chief examiner, I am highly experienced, I'm a bit no-nonsense at this point in the season, and I'm looking directly for your assessment objectives, your AO1, AO2, and AO3. I'm looking for knowledge, application, and higher-order evaluation. You see, the foundation of statistics isn't just mindlessly crunching numbers. It's a conceptual framework built on precise definitions. If I ask you to compare the mean and median of a highly skewed dataset, I absolutely do not just want you to calculate them. I want to see that you understand the causal relationships. I want you to tell me that the mean is being violently pulled by extreme outliers, while the median stubbornly resists them. I need to see integration. Can you link a box and whisker plot directly back to your calculated interquartile range? That specific conceptual mastery is the exact beacon that signals to me, I am grading an A-star candidate. And this brings us to a massive differentiator. Examiners heavily, and I mean heavily, reward analytical depth and cross-topic connections over just a superficial breadth of knowledge. Imagine we are monitoring a live recording of 2 students actively debating how to tackle a question. Let's call student Alpha Alex and student Beta Sam. Now, Alex is the kind of candidate who dumps massive, completely unorganized paragraphs of basic facts onto the page. He is sitting there insisting on listing the textbook definition of variance line by line, hoping anything sticks. As an examiner, this is exhausting. It causes me to search desperately through a wall of text for actual analysis. Then you have Sam. Sam writes with beautiful flair, lovely handwriting, but completely dances around the core command word. If the command word is evaluate, Sam just discusses. Sam argues that bringing in related concepts is enough, but without an evaluative thesis link, I have to penalize the script for a lack of critical depth. Sam gives me superficial breadth. What I crave, what the mark scheme rigorously demands, is analytical depth. I need structured reasoning that directly hits those command words right between the eyes. Moving on to Section 2, the procedural framework. Let's break down the actual methodology of tackling a complex problem. So how do you actually put pen to paper when the clock is aggressively ticking down in that quiet exam hall? When you're faced with a massive, intimidating data matrix asking you to calculate mean or variance, how do you extract the single highest yielding trend without entirely panicking? Let's say you're given a monstrous grouped frequency table. It's got cumulative frequencies, class boundaries, and midpoints all jumbled together. Honestly, it is designed to overwhelm you. It's a stress test. The secret here is procedural processing. You do not just sit there staring at the matrix, hoping the answer reveals itself. You systematically break it down. You use this exact 5-step standardized sequence, and you make sure every single step is explicitly documented for my marking desk. Step 1, identify the key elements. Literally circle your class boundaries and midpoints. Step 2, apply principles. Physically write down the formula for the estimated mean before you plug a single number in. Step 3, execute with clear working. Show me the sum of your frequencies times midpoints. Let me see the engine running. Step 4, verify your results. Take a breath and ask yourself, does this calculated mean actually fall within the central range of my raw data, or did I miss a decimal? And finally, step 5, present in an appropriate format. If Cambridge asks for 3 significant figures, you give me exactly 3 significant figures. Not 2, not 4, 3. Let's move into section 3, securing method marks. This is all about the execution. Let's drop back in on our 2 students, Alex and Sam, who are currently clashing over structural execution on a brutal standard deviation question. Alex is getting frustrated. He says, look, I know exactly how to use the stats function on my scientific calculator. I'm just going to type in the data matrix and write down the final standard deviation. It saves so much time. Sam immediately fires back, arguing, no, Alex, you can't. The command word literally says, calculate and show your working. If you just write the final answer and you mistyped even 1 single digit in your calculator, you get 0 marks for a 5-mark question. Sam is 100% correct. This is the method mark strategy in action. When I'm looking at your paper, I am actively searching your script for clear working to award you process points. I want to give you those marks. But if you hide your process in your calculator, my hands are tied. To guarantee those method marks, your presentation has to follow some incredibly strict conventions. A beautifully formatted table or a perfectly annotated interquartile range calculation signals to me immediately that you are operating at an A tier. It changes my whole posture at the desk. You need to use precise statistical terminology. Please don't write the middle number, write the median. Don't say the spread. Explicitly label your calculation as variance or standard deviation. Your visual representations, like cumulative frequency curves, must have clear headings and strictly annotated axes. When I see this level of organization, my mark per minute velocity increases. It makes my job fast and seamless. And let me tell you a secret, a happy, fast-moving examiner is a generous examiner. Timeout. Before we jump into section 4 and I grade this final model paragraph to show you the fatal mistake that costs thousands of candidates their A-star, let's secure your own academic trajectory. Hit the subscribe button for Ace the Exams at the handle @AceExams right now and turn on all notifications. Whether you are sitting for IGCSE, O-levels, AS, or A-levels, this explainer series is your direct channel to outsmart the marking desk. Okay, let's resume. Section 4, Evaluating Evidence and Data. Our students, Alex and Sam, have just hit a massive logical roadblock mid-argument. Their statistical evidence has completely stopped supporting their conclusion about the data's skewness, and they are stuck. This is the exact moment a candidate either drops into a failing threshold or secures an A-star. To fix their roadblock, I would step in and deploy the PEEL structure. Point, evidence, evaluation, link. You see, standard candidates just accept the given data at face value. If the data says the mean is 50, they just write the mean is 50. It's descriptive. But top-scoring candidates, they question the assumptions. They write, while the mean is 50, considering the extreme outlier of 120, the median of 35 is actually a far superior measure of central tendency for this specific real-world context. Boom. That is how you flawlessly reconnect the argument string and show true critical analysis. So, when you are interpreting relationships in your data, you must explicitly deploy these 4 analytical steps out loud on the page. First, identify data limitations. Is the sample size simply too small to be reliable? Second, highlight assumptions made. Are we assuming a normal distribution when the data is clearly positively skewed? Third, provide alternative interpretations. Could this high variance be due to 2 distinct overlapping subgroups rather than just overall random noise? And fourth, analyze the effects on the final conclusions. If you actively critique the numbers you just spent 5 minutes calculating, you demonstrate elite evaluative thinking to the marking desk. Moving into section 5, the top 3 examiner warnings. It's time for a live data audit. I am literally handing my digital grading pen over to you right now for an interactive live marking workshop. There are exactly 3 major pitfalls you absolutely must avoid when sitting this exam. These are 3 universally fatal errors that I see repeated script after script, hour after hour during the peak of marking season. Let's read directly from the Principal Examiner Report findings. Number 1, answers are too vague, specific details are required. Number 2, students completely forget to check their format and presentation. Number 3, answers are not specific to the provided context. If you dump unorganized paragraphs of vague facts, if you totally ignore your formatting, or if you dance around the specific context of the question, for example, if you talk about the range of data when the question specifically asks you to analyze the range of temperatures in a greenhouse, I will heavily penalize your script. You forfeit critical, easy marks simply because your answer floats in the clouds and lacks real-world anchor points. Challenge time. Look at this live marking audit table on the screen. Let's spot the penalty. I've got my digital red marker out. A flawed standard answer simply says, the range is large. That is descriptive fluff. Where are my 5 marks going? Nowhere. Now look at the top tier answer. It replaces that fluff with, the range of 45 indicates high variability in the daily greenhouse temperatures, suggesting inconsistent heating mechanisms. Do you see the profound difference there? Messy, unlinked equations are entirely replaced by a step-by-step peel structure with clear notation. Generic textbook definitions are replaced by definitions applied directly and forcefully to the scenario. That exact transition is where the weak link is broken, and a terrifying 5-mark penalty instantly turns into full, glorious credit. Finally, Section 6, the final exam strategy. It is time to deconstruct and execute. This is the moment where Alex and Sam, having resolved their clash, finally assemble their completed, flawless response paragraph out loud, line by line. And as they do, I get to happily type a perfect full-mark score into the Cambridge portal. I want you to burn this exact workflow into your memory right now. Let's distill this entire explainer session into 3 universal marking truths. First, respect the 15-second structure scan. Your layout must immediately project absolute competence to me before I even read a word. Second, master the mark per minute velocity rule. Make it incredibly easy and obvious for me to find your working so I can award you points rapidly. And third, execute the final quality review pass using these 5 steps. Deconstruct the prompt, extract your relevant data, select your analytical framework, execute your notation flawlessly, and present it with precise examiner-approved terminology. If you do this, you literally become examiner-proof. So the ultimate question I have for you is this. Now that you know exactly what the examiner is experiencing on the other side of the screen, how are you going to structure your very next practice paper to guarantee those top-tier marks? Are you going to be an Alex, frantically dumping numbers and praying for a good outcome? Or are you going to be a fully prepared candidate, executing the method mark strategy to outsmart the mocking desk? Before you go, make sure you subscribe to Ace the Exams at the handle @AceExams. Click that notification bell so you don't miss our weekly examiner breakdowns. And right now, I want you to leave a comment below stating your specific subject, your qualification level, and your current target grade. Put it out there and commit to it. Apply these rules, rigorously practice those past papers, and I will see you at the marking desk in our next explainer.